Good morning, students. Welcome back to math session on the chapter inverse trigonometric functions. In our last session, we have seen the domain and the range of each of the inverse trigonometric functions. So in today's session, we should consider the properties of inverse trigonometric functions. Okay. Properties of inverse trigonometric functions. Okay. Now, the first property, observe very carefully. What will be the value of sine inverse x? Okay. So sine inverse x is equal to what? This is the property we are supposed to know. We will take one example to see what do we get sine inverse x. Observe this very carefully. If I ask you what will be the value of sine inverse 1 by 2, see how do we find out it? I will keep this sine of as it is, this sine function as it is. We know that image of inverse trigonometric function is what? An angle. If I ask you what is sine inverse 1 by 2, you start thinking for what angle we get the sine value as 1 by 2. It is 30 degree. So what is sine inverse of 1 by 2? It is just 30 degree. Okay. Image of inverse trigonometric function is always an angle. Are you getting my point? Okay. So if I ask you what is sine inverse 1 by 2, you will say that sir, its image is 30 degree. Okay. If I ask you what is sine 30 degree, we know it. We know the values of trigonometric functions of standard angle. According to that, what will be the value of sine of 30 degrees? It is 1 by 2. So when I started finding out sine of sine inverse 1 by 2 value, what answer I am getting here, dear students? I am getting answer as 1 divided by 2. Is it clear? So when I started finding out sine of sine inverse of 1 by 2, what answer I am getting? I am getting same 1 divided by 2. By looking at this particular example, you can say that sine of sine inverse x is equal to what? It is equal to x. Okay. If it is not clear, let me to take one more example. So if I ask you what is sine of sine inverse 1 by 2, how do we find out its value? I will keep this sine function as it is, sine of. We know its value already. What will be the value of sine inverse of 1 upon root 2? It is 45 degree. Is that not? You should never forget, dear students, that image of inverse trigonometric function is always an angle. Okay. So to get value as 1 by root 2, what must be the angle with sine? 45 degrees. So sine inverse of 1 by root 2 value is what? 45 degree. Okay. What is sine 45 degree value? It is 1 by root 2. So what is the value of sine inverse of 1 by root 2? We get same 1 by root 2. That's why we say that sine of sine inverse x is nothing but x only. And this result holds good if x belongs to the domain of inverse trigonometric function. You cannot say that sine inverse of 2 value is 2. You cannot say this because this x value doesn't belong to this domain of inverse sine function. So sine inverse of x is equal to x if x lies in the domain of inverse sine function. Otherwise, I cannot find out value. First thing. Next. Cos of cos inverse x. What will be the value of cos inverse x? It is just x. Cos of cos inverse x, its entire value is equal to what? X. If x lies within the domain of inverse cosine function. Third property. So tan of tan inverse x is equal to x if x belongs to the domain of inverse tan function. Cot of cot inverse x is equal to x where x belongs to R. Secant of secant inverse x is equal to x if x belongs to R minus open interval minus 1 to 1. Cosecant of cosecant inverse x is equal to x where x belongs to R minus open interval minus 1 to plus 1. In our last session, we have seen the domain of each of the inverse trigonometric function, isn't not? Okay, and all these results hold good if x value lies in the respective domain of each inverse trigonometric function. Okay. How to remember it? So you can remember it like this. If I ask you sine of sine inverse 1 by 2, our answer will be what directly it is 1 by 2. We can remember like this, sine and sine inverse cancel, so we get value as what 1 by 2. Actually, we should not say that it will cancel. Sine and sine inverse, they will not cancel. This is just the way to remember. Okay. If I ask you what is tan of tan inverse 1 by root 3, so we will say that answer is 1 by root 3. How to remember it? So tan and tan inverse will cancel out. We get answer as what? 1 by root 3. Okay. If I ask you secant of secant inverse 2, so what will be our answer? It is 2. How to remember it? Second secant inverse will cancel out. Actually, they won't cancel out, dear students. Just I am telling you a way to remember it. Okay. So secant and secant inverse will cancel out. We get answer as what? Okay. Whether these 6 properties are clear to you? So sine and sine inverse cancels out, we get value as x. In fact, they don't cancel out. This is how we remember. Okay, cos and cos inverse will cancel out. We get what value? We get x as the value. Okay. So this is the first property. So next set. As we enter into the problem section, you will become more clear with these properties, dear students. Okay, second one. Sine inverse of sine theta is equal to what? As we followed the logic in the last 6 properties under Roman number 1, same logic we will apply here. Sine inverse and sine cancels, so directly we get what? Theta as the value. This is how we will remember. Okay, so we will take one example to understand it. Sine inverse of sine 30 degree. I have asked you to find out its value. Let us see what do we get its value as. Okay, I will keep this sine inverse as it is. What is sine of 30 degree value? Sine 30 degree value is what? It is 1 by 2. Okay. We remember, we know the values of trigonometric functions of standard angles, is that not? So what will be this sine 30 degree value? According to that table, sine 30 degree value is 1 by 2, is sine inverse is as it is. Now we are having sine inverse 1 by 2. We know that image of inverse trigonometric function is an angle. Okay. So for what angle we get sine value as 1 by 2, that will be the image of sine inverse 1 by 2. So sine inverse of 1 by 2 value is what? 30 degree. What we are getting here, dear students, observe sine inverse of sine theta, we are getting as same theta, is that not? So sine inverse of sine theta is equal to what? Theta. And this result holds good, this result holds good if theta lies within the principal value branch of inverse sine function. I often see many students committing mistake here. If I ask you what is sine inverse of sine 120 degree, in this case you cannot say answer as 120 degree, because whatever the theta value is present here, it is not present in the principal value branch of inverse sine function. Okay, so sine inverse of sine theta is the theta if and only if theta lies within the principal value branch of inverse sine function. If it is sine inverse of sine 60 degree, since theta is present within this closed interval minus pi by 2 to plus pi by 2, what will be our answer directly? Our answer will be 60 degree. Okay. So sine inverse of sine theta is theta if theta lies within the principal value branch of inverse sine function. Is that clear? Okay. Similarly, what is cos inverse of cos theta? Cos inverse of cos theta is theta. How to remember it? Cos inverse and cos will cancel out. We get theta as the value. Actually, I should not say they will cancel out. It's just the way to remember, is it not? Okay. So cos inverse and cos cancels out. We get theta as the value. So this result hold good if theta belongs to the principal value branch of inverse cosine function. So next property. Tan inverse of tan theta. Tan inverse of tan theta is theta. What is the principal value branch of inverse tan function? Yes, if theta belongs to open interval minus pi by 2 to plus pi by 2. In my last session, we have seen that table that tells us the domain and range of each of the inverse trigonometric function. Okay, fourth property. Cot inverse of cot theta is equal to what? Theta. How to remember it? Cot inverse and cot will cancel out. Directly we get theta as its answer. And this result holds good if theta lies within the principal value branch of inverse cotangent function. Next, secant inverse of secant theta is theta if theta belongs to the principal value branch of inverse secant function. What is the principal value branch of inverse secant function? Closed interval 0, pi excluding pi by 2. Is that not? Next, sixth property under this, cosecant inverse of cosec theta is equal to theta if theta belongs to the principal value branch of inverse cosecant function. Okay. Whether these properties are clear, let us try to recall these properties with some examples. See here. If I ask you what is the sine of sine inverse 1 by 2, what will be your answer? Already I have said you the logic to remember it. What will be the value of sine inverse 1 by 2? Directly we will think in this way. Sine and sine inverse will cancel out. We get value as what? 1 by 2. Okay. If I ask you what is tan inverse of tan 30 degree, we know the logic. What logic we are remembering? Tan inverse and tan will cancel out. So tan inverse of tan 30 degree value is equal to what directly? 30 degree. Okay. So if I use the word cancels, it is just to make you to remember the things. Actually, they won't cancel out. On simplifying, we get value as 30 degree. This is how we remember. We remember that tan inverse and tan will cancel out. We get answer as what is students? 30 degree. Okay. If I ask you secant of secant inverse 2, without taking much of the time, you must be in a position to answer what? Sec and sec inverse will cancel out. So we can answer as what? Okay, these are the properties you need to remember. Next set of properties. In the first set we have seen 6 properties, in the second set we have seen 6 properties, in third set we are going to see the 3 properties. Prove the following. In our annual examination, they can ask these properties to prove. Okay. First 2 sets of properties which I have discussed, their proof is not there in our syllabus. So I didn't speak of them. But now, whatever the properties we are going to consider, we are going to prove them. Is that clear? Okay. So in this, prove the following. The very first property we are going to discuss is sine inverse of 1 by x is equal to cosecant inverse x. Okay. And this result hold good. This result holds good if x belongs to R minus open interval minus 1 to plus 1. So this is the property we are supposed to prove. That is sine inverse of 1 by x equal to cosecant inverse x, where x belongs to R minus open interval minus 1 to plus 1. Okay. Now see how do we prove it. So what we will do here is, we will take this sine inverse 1 by x as theta. So left hand side we will take it as theta. You may be thinking, sir, how can you take sine inverse 1 by x as theta? Image of any inverse trigonometric function you take, dear students, it is always what? An angle. So I can assume that this left hand side, that is sine inverse of 1 by x, is equal to theta. By taking sine inverse of 1 by x equal to theta, I will prove that sine inverse 1 by x is equal to our cosecant inverse x. See how do we do it now. This implies, if you recall the definition of inverse sine function, if sine theta is equal to x, then theta is equal to what? Theta is equal to what? Sine inverse x. How do we remember it? If sine moves to the right side, it becomes sine inverse. If sine inverse moves to the left side, it becomes sine. Okay. Actually, sine will not move. This is according to the definition. But to remember, we can remember like this: sine goes here, sine inverse comes here, like this. Okay. So I have taken sine inverse of 1 by x equal to theta. By the definition, what I can say? I will move this sine inverse to the right side. Okay. Then 1 by x will be equal to what? According to the definition, 1 by x equal to sine inverse. If it moves to the right side, what do we get? We get sine theta. Okay. So what do we get? 1 by x equal to sine theta. Right now. In the final answer, I want even cosec function, cosecant inverse x. So here there is no cosec. Now I need to apply the step such that I will be getting that cosec function also. How do we write cosec theta? We know reciprocal relations. Cosec theta is nothing but 1 upon sin theta. Now I will take reciprocal on both sides. Taking reciprocal on both sides. So you need not to bypart it. You need not to mug it out. Okay. We know that we want answer in terms of cosecant inverse x. So I need 1 divided by sine. 1 divided by sine, as we know, it is cosec theta. Is that not, yes, students? That's why on both sides we will take reciprocal. So what is reciprocal of 1 by x? It is x. What is reciprocal of sine theta? It is 1 upon sine theta. Is it clear up to here? Further, x is equal to, what is 1 divided by sine theta? 1 divided by sine theta is cosec theta. So I want cosecant inverse x. If I take this cosec function to left side, it will become what? Cosecant inverse. Actually, I should not use that word take left side, right side. This is the way to remember. Again and again I repeat. Okay, if I take this cosec to the left side, what does it become, dear students? It becomes a cosecant inverse x is equal to theta. Finally, cosecant inverse x equal to theta is nothing but whatever sine inverse 1 by x. So in the place of theta, finally you will write down sine inverse 1 by x. This is the proof. Is that clear? Observe each and every step. To prove sine inverse of 1 by x equal to cosecant inverse x, what we have done? We have taken the sine inverse 1 by x as a theta. According to the definition of inverse sine function, this 1 by x will be equal to what? Sine theta. In the answer, I want cosecant inverse x. Is that not? So now I need to apply the step such that I will get cosecant. For that, we have taken reciprocal on both sides. What is reciprocal of 1 by x? It is just x. What is reciprocal of sin theta? 1 divided by sin theta. So this x is kept as it is. What is 1 divided by sin theta? 1 divided by sin theta is cosec theta. According to the definition, if x is equal to cosec theta, this theta will be equal to what? This theta will be equal to cosecant inverse x. So cosecant inverse x equal to theta is nothing but our sine inverse 1 upon x. Okay. Next. Tan inverse of 1 by x equal to cot inverse x. This result holds good if x is greater than 0. Each of the result associated with inverse trigonometric function holds good for some values of x. In detail, we are not going to discuss for what values of x this result is going to hold good. Just we need to remember. Okay. Is that clear, dear students? So this result holds good for x value greater than 0. Now, how to prove it? Same what we have done in the last case. What we will do here, we will take tan inverse of 1 by x as theta. You may be thinking, sir, if I take cot inverse x as theta, do I get the answer? Yes, you can go with that way also. Okay, both are right approaches. So here I will consider LHS as theta and after applying the steps we get that LHS and RHS both are same. Okay, so let tan inverse 1 by x is equal to theta. Okay, so according to the definition now, how can you write this? Already I have said you the way to remember tan inverse if I move to the right side. Okay, then what is 1 by x equal to? 1 by x equal to tan theta. 1 by x is equal to tan inverse. If you move to the right side, it will become tan theta. So we get 1 by x equal to tan theta. I want answer in terms of cot inverse x. It means I must have cot theta function. So what is cot theta? Cot theta is nothing but 1 upon tan theta. Now I came to know that I need to take reciprocal on both sides. Taking reciprocal on both sides. Okay. So what is reciprocal of 1 by x? Reciprocal of 1 by x is just x. What is reciprocal of tan theta? It is 1 divided by tan theta. Right? Further, x equals to, what is 1 divided by tan theta? 1 divided by tan theta is nothing but our cot theta. So we are close to the answer. Now what we will do now? If x is equal to cot theta, according to the definition of inverse, theta will be equal to what? Cot inverse x. Cot anna nanu ee kade tagondre ಏನು ಆಗ್ತದೆ? Cot inverse ಆಗ್ತದೆ. Okay. Then cot inverse x is equal to theta. Okay. So cot inverse x equal to theta is what? We have assumed that theta is tan inverse 1 by x. This is the proof for the second result. Observe each and every step here, dear student. So tan inverse 1 by x is equal to cot inverse x. This is what I need to prove. And remember, this result holds good for what? X values. This result holds good for x greater than 0. Discussing the domain for which these results hold good is beyond the scope of our syllabus. Just we will remember. So this result tan inverse of 1 by x equal to cot inverse x holds good if x is greater than 0. Okay. Now, how do we do it? We have taken LHS as theta. What is there at left hand side? In left hand side we are having tan inverse 1 by x. How can we take tan inverse of 1 by x as theta? We know that image of any inverse trigonometric function is an angle. Is that not? Do you agree? The image of any inverse trigonometric function is what? An angle. So we have taken tan inverse of 1 by x equal to theta. According to the definition of inverse, tan inverse, if I take to the right side, tan theta will be equal to what? 1 by x. In the final answer, I need what? Cot inverse of x. So I must apply the step such that I will get cot theta even. Okay. So what is cot theta? Cot theta is 1 by tan theta. This tells me that I need to take reciprocal here. Reciprocal of 1 by x is x. Reciprocal of tan theta is 1 by tan theta. So x equals to, what is 1 divided by tan theta? 1 divided by tan theta is our cot theta. Finally, according to the definition of inverse cotangent function, if I take cot to the left side, if cot is taken to the left side, it will become cot inverse x equal to theta. Cot inverse x equal to theta. So what is finally theta we have taken as tan inverse 1 by x. This is the proof for this second result. Okay. Next one. There are chances that in our board examination they may ask us the proof. So practice the proofs even. Third one, cos inverse 1 by x is equal to secant inverse x, where x belongs to R minus open interval minus 1 to plus 1. Okay. Even, dear students, even there are chances that in our annual examination they may ask us the question like this: for what values of x? Two times in our board examination they have raised the question of this format. For what values of x cos inverse of 1 by x equal to secant inverse x holds good? They may ask us the question of this particular format even. Okay, for what values of x this result, which one, cos inverse of 1 by x equal to secant inverse of x holds good. For what values of x means you need to write down the domain for which this particular result is going to exist. Okay, so this result exists if x value belongs to this particular interval. Okay, so if question is like this, for what values of x this result holds good, you need to write down this as the answer, only this much. You need not to prove entirely the result. We are asked to write down the domain. Okay, shall we prove it with the same as that of the first two? So what we will do here, dear students, already we are familiar with the process. Yes, procedure. What we will do, we will take cos inverse of 1 by x as the theta. So cos inverse of 1 by x is equal to theta. This implies, according to the definition, how can you write this? 1 by x equal to cos inverse. If I move to the right side, it becomes cos theta. So we get 1 by x equal to what? Cos theta. Okay. This is according to the definition of inverse cosine function. So next what we will do, we will take a reciprocal on both sides. Why do we take reciprocal? You need not to bipart it. Yes, why we will take reciprocal on both sides? Because in the answer I want secant inverse x. What is secant theta? 1 divided by cos theta. So I need a term such 1 by cos theta. So I need to take reciprocal on both sides. Taking reciprocal on both sides. So reciprocal of 1 by x is x. Reciprocal of cos theta is 1 divided by cos theta. Okay. Finally, x equal to what is 1 divided by cos theta? This is a sec theta. Now according to the definition of inverse secant function, if x is equal to sec theta, if I take this sec to the left side, what do we get? Secant inverse x equal to theta. Okay. So secant inverse x equal to what is our theta? Theta is nothing but cos inverse of 1 divided by x. Okay. Whether proof is very clear to you? Right. Next, set of properties. Prove the following. Prove the following. In that first one, sin inverse x plus cos inverse x equal to pi by 2. And this result holds good. You need to remember these x values even. This result holds good if x belongs to closed interval minus 1 to plus 1. Okay, that is natural natural, yes, domain of each of these two functions. That is, x belongs to closed interval -1 to +1. Okay. Now, how to prove it? So once this question has appeared in our board examination for 2 marks, very simple proof. If you remember the proof of this property, that is sin inverse x plus cos inverse x equal to pi by 2, we are having 2 more such properties. Okay. So how to prove it? Observe very carefully. If this proof is very clear to you, next 2 results we can prove very easily. Okay. Now, so in left hand side, dear students, we are having 2 inverse trigonometric functions, that is sin inverse x and cos inverse x. We will take one of the inverse trigonometric functions equal to theta. Either you take sin inverse x equal to theta or cos inverse x equal to theta. It is left to you. Here I will take sin inverse x as theta. Try to understand the proof. Let sin inverse x equal to theta. Even if you want, you can take cos inverse x as theta. That's what I am saying. Take one of the inverse trigonometric functions as a theta. Whether you take sin inverse x equal to theta or cos inverse x equal to theta, it is left to you. Here I have taken what? Sin inverse x equal to theta. Okay. So according to the definition of inverse sine function, x will be equal to what? S. Now you are in a position. X is equal to what? Sin inverse. If I move to the right side, x is equal to what? It is sin theta. Okay. Now, in the final answer, even I need what? Cos inverse x term. So now I will apply the step such that I will get a cos term. But here I cannot take reciprocal because reciprocal of sin theta is what? Cosecant theta. I don't get cos out of it. So taking reciprocal doesn't give any meaning here. So what shall we do? We shall use the trigonometric functions of allied angle or trigonometric functions of compound angle. If you remember this formula, observe this formula. So how can I write sin theta? Yes, sin theta is equal to what? Do you remember this? Cos of 90 minus theta. Allied angle formula, dear students. See, 90 minus theta lies where? In the first quadrant. So I have got here plus sign. If allied angle is of the form 90 minus theta, cos changes to its co-function, that is sine. Okay? So if we want, how can we write sin theta? Sin theta can be written as what? Cos of 90 minus theta. Since I want answer in terms of cos inverse, answer nalli nanu cos inverse nu beku. Hagagi I will apply the formula such that I will express this sin theta in terms of cos theta. Okay. So further, observe very carefully. X is equal to, okay, so sin theta can be written as what? Sin theta can be written as cos of 90 minus theta. These two are co-functions. You can write sin theta as a cos of 90 minus theta and cos theta as what? Sin of 90 minus theta. We can write sin theta as cos of 90 minus theta or cos theta as sin of 90 minus theta, because one and the sin theta and cos theta, they are the co-functions, complementary functions of one another. That's why sin theta can be written as cos of 90 minus theta and this cos theta can be written as sin of 90 minus theta. Okay. So now this x is equal to what? Sin theta. This sin theta, how we have written? Cos of 90 minus theta. So now, according to the definition of inverse cosine function, if I take this cos to the left side, only cos, it will become cos inverse. If it is function here, it will become what? Inverse of that function. See, We remember the definition of inverse of a function. If f of x is equal to y, x is equal to what? F inverse of y. If it is f here, if this f is moved to another side, it will become what? F inverse. Okay, similarly, so here it is cosine function. If I shift it to the left side, it will become inverse cosine. So it will become cos inverse x equal to pi by 2 minus theta. Further, cos inverse x equal to pi by 2 minus, what is theta? We have taken theta as sin inverse x. Further, take this minus sin inverse x to the left side, it will become what? Plus sin inverse x. So it becomes sin inverse x plus cos inverse x equal to pi by 2. This is the proof. Okay. This is very important from your board examination point of view. We can expect such questions in our board examination. See, what is the result we are supposed to prove here? We are supposed to prove sin inverse x plus cos inverse x equal to pi by 2. How do we prove it? So we will take one of the inverse trigonometric functions as theta. Either you take sin inverse x equal to theta or cos inverse x equal to theta. It doesn't make any difference. But you need to take one of the inverse trigonometric functions as theta. Here I have taken sin inverse of x equal to theta. According to the definition of inverse sine function, if I move this sine inverse to the right side, only function, sine inverse to the right side, we get x equal to sine theta. Okay. Since in the answer I want inverse cosine function, I will apply the formula such that the sine theta I will express in terms of cos. So what will be sine theta equals to cos of 90 minus theta. Already we have learned it. So what will be our sine theta? Sine theta is equal to cos of 90 minus theta. So if I take this cos to the left side, actually I should not use that word taking cos to the left side. For understanding purpose, I use that word. Actually it is according to the definition. Okay. So if I move this cos to the left side, it is cos inverse x equal to pi by 2 minus theta. We know that theta is nothing but our sin inverse x. If I take this minus sin inverse x to the left side, it becomes plus sin inverse. So sin inverse x plus cos inverse x equal to what? Pi by 2. Next. Second one. Tan inverse x plus cot inverse x equal to pi by 2. Even I will tell you the logic to remember the formula. Okay, at the end I will tell you the logic to remember all the formulae. First we will prove them one by one. Okay. So now I want to prove that tan inverse x plus cot inverse x equal to pi by 2. This result holds good for all x belongs to R, which is the domain of each of these two inverse functions. This is very simple to remember in these formulae. So when I proved sin inverse x plus cos inverse x equal to pi by 2, there we say that x must present in the closed interval minus 1 to plus 1. Closed interval minus 1 to plus 1 is nothing but domain of sin inverse x or cos inverse x. Okay. There remembering x value is simple. Here also remembering x value is quite simple. Very easy here. Okay. So this R is nothing but domain of tan inverse x as well as cot inverse x. So now how do we prove it? Same procedure will be followed here. Okay, let tan inverse x is equal to theta. Dear students, even if you want, you can take cot inverse x as theta, it is up to you. So here I have taken tan inverse x equal to theta. According to the definition, x will be equal to what? Now you are in a position to understand it, right? So if I take this tan inverse to the right side, according to the definition, x will be equal to what? Tan theta. Okay. Now you must think, in the final answer I need what? Cot inverse x also. So here you need to apply the step such that this tan theta will be expressed in terms of cot. For that we are having a light formula. What is that? Tan theta can be written as cot of 90 minus theta, and cot theta can be written as tan of 90 minus theta. Tan theta and cot theta, they are co-functions of one another. So tan theta can be written as cot of 90 minus theta. Cot theta can be written as tan of 90 minus theta. So now x equal to this tan theta. Now I will write it as what? Cot of 90 minus theta. Many students generally they find trigonometry as difficult only due to the formulae. We need to remember here so many formulae, dear students. Okay. As we practice more and more, it becomes very easy to remember the formula. That is also not a big deal, right? Okay. So x is equal to this tan theta. How we have written? Tan theta we have written it as cot of 90 minus theta. In next step, I want in answer cot inverse x. It will tell me that I need to use the definition of inverse of a function. If I shift this cot to the left side, it will become what? Cot inverse. Function will become inverse. Okay, cot will become cot inverse x equal to pi by 2 minus theta. Further, cot inverse x equal to pi by 2 minus theta is what? Tan inverse x. Now take this tan inverse x to the left side, it will become plus tan inverse x. So tan inverse x plus cot inverse x equals to pi by 2. This is the proof for the second result. Okay. Last one. Practice more and more. Their proofs are very important from board examination point of view. Right? Third one. Secant inverse x plus cosecant inverse x equal to pi by 2. This result holds good for x belongs to R minus open interval minus 1 to plus 1, which is the domain of secant inverse x as well as cosecant inverse x. How to prove it? Same way. Okay. What we will do here, we will take one of the inverse trigonometric function as theta. Let secant inverse x equal to theta. Even if you want, you can take cosecant inverse x theta. It is up to you. Okay. So I have taken secant inverse of x as theta. According to the definition of inverse, x is equal to what? Now, you dear students, you are in a position to understand it. What is x equal to? If I move secant inverse function to the right side, it becomes function. So x is equal to what? Sec theta. Now you need to apply such that you will get cosecant theta also. For that we are having one formula. What is that? Sec theta is nothing but cosecant of 90 minus theta. Right? Sec theta na nahi barkobodri cosec of 90 minus theta anta barkobodri. And how can I write cosec theta? Cosec theta, I can write it as secant of 90 minus theta. Okay. Sin theta we can write as cos of 90 minus theta. Cos theta we can write it as sin of 90 minus theta. Similarly, tan theta can be written as cot of 90 minus theta. Cot theta can be written as tan of 90 minus theta. Similarly, sec theta is written as cosecant of 90 minus theta. And cosecant theta is written as secant of 90 minus theta. Okay. So now I will write the secant theta as cosecant of 90 minus theta. Okay, we need not to bypass it. It is very easy. In the final answer, I need even cosecant inverse of x function. For that reason, we need a formula. We will apply a formula such that the secant theta will be expressed in terms of cosec function. So secant theta will become what? Cosecant of 90 minus theta. So we want inverse cosecant function. So according to the definition, this will become what, dear students? It will become cosecant inverse x. This cosec I have shifted to the right side. Function will become inverse. Okay. So cosecant inverse x equal to pi by 2 minus theta. Cosecant inverse x equal to pi by 2 minus theta is what? Theta is the secant inverse x. Okay. Take this minus secant inverse x to the left side, it becomes plus secant inverse x. So secant inverse x plus cosecant inverse x equal to pi by 2. Okay, this is how we do. Now, how to remember these three formulae? So, totally there are three results in terms of pi by 2. I will tell you the way to remember these three pi by 2 formulae, dear student. Just remember the logic. Okay. Now, if you take a sine function, what is its co-function? Cosine. When I ask you to say co, just add co to that function. Sine co-function ಏನಾಗ್ತದೆ cosine. If I ask you co-function of cosine, remove co, what do we get? Sine. So sine function and cosine functions are co-functions of one another. What is co-function of tan? Cot function. What is co-function of cot? Tan. What is co-function of sec? Cosec. What is co-function of cosec? Sec. So we are now familiar. Sine function and cosine function are co-functions. Tan function and cotan functions are co-functions. Sec function and cosec functions are co-functions. Sine, cos, tan function, cot, sec, cosec. So pi by 2 formula also same. Sine inverse x, co-function of sine x is cos. So cos inverse x pi by 2. We can easily remember. In terms of trigonometry, I am telling you, sine's co-function is cosine. So you can remember sine inverse x plus cos inverse x is pi by 2. Co-function of tan theta is what? Cot theta. Cot theta. So formula is what? Tan inverse x. Just add co to it. Cot inverse x equal to pi by 2. Similarly, sec inverse x. Just add the word co to it. It will become cosecant inverse x equal to pi by 2. Okay. These are the three results which contain pi by 2. Is that clear? Now I am in a position to remember this formula? Yes. Okay. In tomorrow's session, we shall consider few more properties and we will solve the first exercise of your chapter inverse trigonometric functions in tomorrow's class. Okay. If you have got any doubts, let me know in the chat box. Today I have kept a live chat on. So if you are having any sorts of doubt, you can ask me the doubt in the chat box. Even you can ask me the doubt in WhatsApp group. Okay? Thank you.